Hello, I'm Dr. Ron England, and this is COP 3530, Data Structures. And today we're going to learn a little bit about the actual course itself. What is it that you need to get out of this course, and why are you here and taking this course? That's actually kind of important for you to understand as you're going into this course. What do you need to know to be successful in this course? There are prerequisites, but there's actually prerequisite knowledge that you have to have any level of success in this course. And also have an understanding of what the outcomes of the data structures course is, because data structures is a required course for every computer science and every IT professional. So this is a course that's considered to be fundamental to everybody in the field. So we're going to talk about all of those, but let's first talk about what actually is a data structure. Well, if you're using a computer, and you should have some familiarity with things on the computer, you would understand that a data structure, everything on the computer is organized in some sort of fashion. When you put input into a computer, it's stored in a certain way, it's presented in a certain way. Well, behind the scenes, there are structures of how we take this information and we structure it so that we can easily get access to it. And from the point of view of a programmer, you will look at it, and also from the point of view of a user. But really, it's going to be from the point of view of a programmer, somebody who's actually building things on a computer. There are structures of very primitive types, all the way down to a bit, a byte, okay, all the way up to floats and integers and strings and numbers. But those things are actually, those primitives are things that can be built on top of. But they're also things that can be part of. What we're going to cover is what they're part of. How do you build structures out of the things that you've got on a computer so that you can easily get that information back? So to do this, we're going to need to understand the concept of an abstract data type, because this course has a certain amount of theory and a certain amount of practice. And an abstract data type is something that's actually defined by its behavior. In other words, if it walks like a duck and talks like a duck, it's probably a duck. But we're going to define a duck as something that walks a certain way and talks a certain way. So by defining this concept of an abstract data type, something that behaves a certain way, we have this ability to implement that thing. Well, we can implement that thing, and if you're doing a duck, you may end up with a duck or you may end up with a goose, but if they're defined by how they walk and talk, and well, geese do honk and ducks quack, but they sound a lot the same. But if they're defined by those things of how you observe them, then they're considered to be abstractions. And an abstract data type is just that. It's an abstraction of a concrete thing. Now, we are not just going to deal with the abstract sense here. We're going to actually implement these abstract data types. And when you do that, you have an actual data structure. And different ways of implementing have advantages and have disadvantages. And what you want to know is how to determine what those advantages and disadvantages are. The other concept here is the concept of an interface. Well, an interface is how you define that walk and talk. You say, in an abstract data type, you may say it implements the function add and it allows you to add things to it. Well, that may be one function that has a specific purpose, which is easy to understand, and many abstract data types may have that function add, but as you get deeper and deeper into the abstract data type, they have more and more different types of functions that allows you to differentiate between the different abstract data types. Now, why are you taking data structures? Well, outside of the fact that it's one of the most important courses to get the fundamental theory behind all of computer programming, it's how things are stored. You learn everything actually has a specific structure. And the definition of how this structure is going to work, okay, then abstracted up to a level higher and then a level higher allows you to build more complex things on top of simple things. And because in today's world, what you program on a computer is extremely complex, there's a level that you've got to get down to those simple basics that you need to understand before you can build those complex things on top of it. Now, the goals of building data structures, well, we're really interested in efficiency. Okay, whether it's computational efficiency or storage efficiency, okay, or whether you can search and retrieve, And to give you an example, one of the biggest companies and the most profitable companies in the world was built on top of an algorithm, was built on top of a data structure. And that company is Google. Google has been able to optimize the concept of search. And they have an algorithm that makes it so that you can bring back millions of results in less than a second. It has a tremendous value. That structure and how they do that has a tremendous amount of value. But you're going to learn the fundamentals of how these things actually work. Now, is this going to be important to you? Well, if you're going to go work in any major company as a programmer, and you go through technical interviews, which if you're going in as a programmer, you are likely going to always be going through technical interviews. Those interviews are going to contain questions about data structures. Okay, the Microsoft interview process takes you through an entire, very rigorous background and how well do you know and understand data structures. So understanding it is kind of important. And you know, as I've told you, that because of the building blocks of everything in the computer, and data structures encompasses the analysis of algorithmic efficiency and actually encompasses a lot of algorithmics, those abilities are just the basic abilities of being a solid computer programmer. Now, what do you need to know before you start this course? Well, hopefully you've had the prerequisite, which is normally going to be about a year of programming. And yes, you do, absolutely do need to know how to program. You need to be able to sit down, write a for loop, write an if-then, write a switch case, do else statements. All those basic things, the tools and structures that you have, you need to be able to create functions, you need to know how to call functions, you need to know how to pass arguments to functions, and need to understand what is the actual mechanism when you pass things to a function. Okay, this is fundamental, basic procedural programming. If you haven't had a course in object-oriented programming, you don't need to fret because we are going to cover objects and we are going to use JavaScript and build objects. But much of what you need to know in building objects, we are going to cover in the course. So the concepts of building objects and using pointers, we are going to cover. But you must absolutely know how to do the basic algorithmics. Again, and don't fret if you don't. There are plenty of excellent programming classes here at Daytona State that you can take to build up that capability. It doesn't matter what language you're using. I recommend languages like Java or maybe C++. They're both object-oriented languages and they both support very strong procedural programming. Those are a good, solid basis. But even if you just know C and standard procedural programming, you can still be successful. Now let's look a little bit about what you're going to get out of this course. There are 4 primary objectives of this course. You need to be able to describe both complex and simple data structures, and you need to know what the basic data structures are. When we talk list, graph, queue, stack, you need to know what they are. You need to understand their abstractions. You need to understand how to implement them. You need to be able to select the correct data structure to perform a specific task or to be used in a specific algorithm. And you need to be able to look at the efficiency associated with this, and you actually need to be able to implement them. You've got to sit down and code and build that data structure, which is why that programming is so terribly important. And the last piece is that when you've built a data structure and you've written an algorithm, you're going to learn to be able to analyze the performance and give standard notation of what is the performance of your algorithm in the use of that data structure. So here are the basic data structures that we're going to cover in this course. We are going to use arrays, and hopefully you've seen arrays before, but we're also going to use lists. And when I say lists, lists is an abstract data type, and lists actually have sub-abstract data types. So like a specific case of a list would be a queue or a stack. We're going to do trees, and we often call them binary trees, but I'm not going to limit ourselves to just the use of binary trees because there are other types of trees that are not necessarily binary in nature. In a binary tree, it means that you've got basically two branches off of each part of the tree, each node of the tree, each leaf of the tree. Okay, well, we're not going to limit to that, but we're going to really just deal with the binary trees mostly. Hash tables, which you may not have seen before, but you're going to get a lot more in that. And then really one of the more complex data types, the concept of a graph. The basic algorithms will be covered. Searching, sorting, traversal, and then some applications. How do you actually take and write algorithms for specific applications, which utilize the basic algorithms? We're going to analyze and implement those. And we're going to look at efficiency. So we're going to need to look at and understand the efficiency of the algorithms that we write and the data structures that we use. So looking back at what we're going to actually do in this course, you should have, by now, at least know what we mean when we say the field of data structures. You need to be able to explain, why is this important? Why are you having to take this course? And why is this a fundamental course in all of computer science and IT? You are also going to need to know what you need to know to be successful in utilizing data structures and what type of background that you need to have. And you need to know, this is what we're going to get out of this course. We've covered, what is it you're going to learn to do as you take data structures. So hopefully you're excited and ready for an amazingly challenging course. This is one of my favorite courses to teach, and most of my students say this is one of the favorite courses that they've ever had because they really learn the guts. And the guts allow you to do many amazing things. So thank you very much. This is Dr. Ron England signing out from Daytona State College.